So hi guys, welcome to my channel, and today we're gonna talk about the Radix 2 encoding. And this is Radix 2. I think after studying this topic Radix 2 encoding, at first you should know about booth multiplication, and where we just discussed about one thing, that is when we're talking about the multiplier q0 q minus 1. We know this about this one. Okay, I just show you something. Okay, and this is our booth multiplication we just already done in our previous video, and today we're going to talk about something, the booth algorithm, but it is a very backdated form of booth algorithm. But when we just go through the traditional encoding or Radix 2 algorithm, that is actually known as a modified booth algorithm, because using this formula and using this algorithm we just easily find out any types of algorithm. I mean Booth's multiplication. Okay, because it is very easier for us to multiply and to actually to find out the value of the any multiplied form, any number of multiplied form in the binary form actually. So without wasting any time, let's get started. So at first I'm gonna talk about, and I think I just definitely discussed about this q0 q minus 1 funda, and which is where is the 0 0 that should be equals to 0. When the case of 0 0, there should be 1. Okay, I will definitely discuss it again at first. Okay, so what the funda is? The funda is whenever we just talk about this q0 q minus 1 is equal to 0, when that actually means that this q minus 1 is travel towards q0, and when it travels q minus 1 to q0, and when the 0 and 0 will, and when you start from 0 and end with 0, and that should be equals to 0. That's mean no change will be there. Okay, and as according we know that for 0 1, and then we know 1 0, and then we know 1 1. Okay, this we also will ever about this one. I think we all know about this. Okay, so don't need to bother about it. Okay, and at first we're gonna talk and then we just definitely, when we start from 1 and then we end our journey from to 0, then we get the flush 1. Okay, the person I just discussed about this one q0 q minus 1 funda on my previous video. Please check it out, and make sure that you will definitely have an idea about it, and then come to this video. But if you don't check it out, but it's okay for that, because I am just explaining now, so don't bother about it. Okay, just stay focused on it. Okay, so when let's suppose, and we just talk about let's come to this point, and when we just talk about when we just start our journey from 0 and we end our journey to 1, that should be, that is that minus. That's mean, okay, we gonna talk about like the after sometimes after in this video, after sometimes in this video we're gonna talk about why this plus 1 is why the plus 1, why I'm writing this plus 1, why I'm writing minus 1. This is bagada bagada. Okay, and when we start from 1 and just in our journey from to 1, that should be equals to 0. That's mean no change will be there. Okay, and this is actually the main fund about q0 and q minus 1. And on my in my previous video I just take a 5 into 6 for our example purpose, and that should be equal to 30, but at first we just need to write this 5 as it is actually decimal form, and we just need to write this decimal form as in binary form, and we know this 5 and if we represent 5 in a binary form, that should be equals to this. And you obviously the plus 5, if 5 means this is plus 5, and plus represent with the 0, and minus represent is 1. I think you know about it. Okay, so don't need to bother about it. Just this is simple form, this is formula, this is simple form. Just whenever just uses plus, and that should be represented with the 0, and whenever write minus, this should be represented with 1. This is a sign expansion. Okay, and this 5 we just need to write this 1 0 1 0 1, because it is like a binary representation of 5, and we just go through the plastic that should be represented by 0 1 1 0. Okay, and we just need to write this multiplication in a binary form, and we just have a look over here that what should be our value, and that should be 30 in a decimal, and it have to be 30 in a binary form. Okay, the what should be a value of this, because in our previous video we definitely discuss about this 5 into 6 and both multiplication, which is the very 4, and as it is a 4 bit, so it should contain 4 step, because I just definitely talk about and discuss about this 4-bit and 4-step funda, and this show 4 step 1 2 3 and 4. Okay, I think, but it is actually a modified form. Why I'm just saying this, because as you all know, because 8 is a 5, 5 is known as the what is 5 is 5 is what 5 is a multiplier. Okay, multiplier, and what 6 is what is a multiplicand. 6 is multiplicand. Okay, okay, just have a look over here. Just you just need to multiply and 5. Okay, whatever, we just in this radix 2 encoding or radix 2, at first we just need to write this multiplier as a coding. Okay, what it is, it is 0 1 0 1. Okay, then we just need to write a dummy 0. It is what, it is dummy 0, dummy 0. Okay, it is known as a dummy 0. So why I'm writing this? Okay, have a look and wait for it. Just we just wait for the twist. When with 0 and 1, that's mean we just have to start our journey from 0, and we have to end our journey from 1, and that end, this is actually quite similar for like this, na? That should be represented as -1, isn't it? Yes. And when we just write our let's suppose we just start our journey from 1 and we end with 0, that should be equals like this, and that should be similar like this, na? So we should represent it +1, and when and as according we just have to do like this. Okay, and when we start our journey from 0 and end with my +1, this should be quite similar to minus, because this is quite similar to this one. We just need to write this -1 as accordingly, and whenever we just write the 0 1, that should be equal, that we just need to write +1 over here, because it is quite similar like this, na? So this is actually, this is what, this is a q0 q-1 funda. We just need to understand about it, because I am just talking about the 2-bit numbers, so I am just writing q0 and q-1. Just why right now I'm writing for this, because whenever I just go through the 3-bit, there should be a way this table should be expand. Okay, okay, so don't need to bother about this one, because we just need to bother about writing 2-bit right now. So don't bother about it, because and stay focused on it. Okay, so what you need to write at first. Okay, now the main funda up to radix to encoding is started right over here right now. Okay, what you should do what you should write now. Oh, at first before entering this radix to encoding, we just need to write the +6 and represented by 0 1 1 0. Okay, because it is our m right now. Okay, because it is a multiplicand, because it is our m. And what is represented by a -m? If -m is nothing but -6, that should be represented by the 0 1 1, just 2's complement +1. Okay, it is a 1's complement +1, that should be represented +2, 2's complement. So it should be represented as 1 0 0 1 +1, and that should be represented as 1 0 1 0. Okay, this is known as a -m, I mean plus -6. Okay, at first we just go through it and as according, and in the radix to encoding, what's the algorithm is, at first we just need to write -1 at first. Okay, -1, that's mean represent -6. Okay, you just need to write 1 0 1 0 at first. Okay, okay, and if as it is minus, so we need to expand it by 1 and dot dot dot, and there will be a many more 1. We just need to write 1 as according, but we know about it. And the next step of this algorithm is we just have to cross this one, because we just entered the next step. Okay, so we just cross a one single thing, and we just need to as it is +1, we just need to take this one +6. So plus 6 is 1 0 1 1 0, and as it is plus, so we just expand it as a 0 0. Okay, okay, okay. And as we enter the third step is nothing but a -1, that should be represented as -6. So we just simply write down 0 1 0 1. Okay, as it is -1, we just expand it -1. Okay, and as we entered the third step, and third step is nothing but a +1, as that's mean we just need to write this +6 as encoding. So at first we're gonna take 0 1 1 0. Okay, okay. Now the addition operation will be done over here. Okay, let's add this sequence. 0 is cross means 0 0 0 0, that should be 0. 1 plus 0 0 0, that means 1. 0 plus 1 plus 0 plus 1 is plus 0, that should be 1. 1 1 1 1 1 1 1, that means 1 1. Okay, 1 1 0 0 1, that should be 1 1. 1 1 1 0, that should be 1 0. 1 1, oh sorry, 1 1 1, that should be 0. 1 1 1 0 1 1 1 0, and we should discard this one. Okay, we should have to discard, because we finish our work over here right now. Okay, in this case, and we just finished our work in this type, in this. Okay, in this, and this is our actually the answer. And if you represent it, so we just have to discard, because it actually you know what, it's actually oversees this one na? So we just have to discard this one. Okay, and if we take this one and you just simply represent it in a decimal form, that should be equals to 2 to the power, that should be what, 2 to the power, it is 0, 2 to the power 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 4, or 2 to the power 3, 2 to the power 4. Why I am writing this one? Because 0, that means we just don't need to write anything. And as it is 2, that should be writing 2 as it is. 2 square, that means 4, 2 cube, that means 8, and 2 to the 4, that means 16. And if we have a total all of this, we can get a 30 over here. And as it is 0 0, we just need to write plus, because I just told about it that 0 means plus and 1 means minus. Okay, minus, and that's it. And it is very easy to understand na? Because and it is actually the Radix to encoding. So hope I think I think I got in my point and got in my Radix to encoding. And if you enjoy this video, so please like, subscribe, and please subscribe and share this video to everyone, to your friends, because it is very helpful for you. And see you guys in the next video. Till then, bye bye, see you.